Hello, welcome to today's class. Today we will look at some things in fraction. The last time we had a talk on fractions, we looked at the introductory aspect of fractions. Today we'll go a step further to look at some operations that involve fractions. Okay, but before we proceed, let's look at the learning objective of the class. By the end of the lesson today, you should be able to do some basic operations on fractions, such as addition of fractions, subtraction, multiplication, and division of fractions. You should also be able to do ordering of fractions according to the order of magnitude. Okay. You should also solve word problems associated with fractions. Okay, word problem and some other form of problems that are associated with fractions. So let's go. So let's go to addition of fractions. That's the first operation we want to do, addition of fractions. So the first thing they ask us to do there is 2 over 3 plus 8 over 3. So now in addition of fractions, this addition and subtraction of fraction, remember if you have watched our video on the introduction to fraction, we looked at some rules of simplifying fractions. So we said that to add and subtract fractions, for you to do that, then the first step or the first thing you must do is to make sure that the denominators of the fractions are the same. Okay, so the first question they gave to us is we have the denominators of the fraction the same. So it is easier for us to just go and add. Is that okay? But then how do we add? Do we just add the numerator and add the denominators? No, we have a way of adding fractions. Remember, fractions are just special kind of numbers, if I will use that word. So let's say the first one we have here is add. So we should add 2 over 3 plus 8 over 3. 2 over 3 plus 8 over 3. So the first thing we do is, since they have the same denominator, okay, 2 ways I will teach you on how to do this. The first one is find the LCM of the 2 denominators. LCM of 2 numbers, of a number that is the same, or 2 numbers that are same, like 3 and 3 is still 3. Do you understand the point now? All right, so how? Let's say this is 3 and this is 3. You know how to do your LCM, right? The factor here is 3, 3 here, 1, 3 here. So this is the LCM, 3. LCM of 2 and 2 is still what? 2. LCM of any number and any number and any number of that same number is the same number. So we bring out the LCM. So we bring out the LCM out, draw a large line, a longer division sign, bring out 3. And this is now what you do. You divide, for each of the fractions, you divide this, their LCM now, this their LCM, the greater LCM, okay, with the denominator of the first fraction. That is, this 3 divided by this should give us what? 1. That is 3 divided by 3 is 1. So once you get that, whatever you get there, you add it to the numerator. That is, this times this, the answer you multiply by this. So 3 divided by 3 is 1. 1 times 2 is 2. So here is 2. Then you bring this plus down. You do same here. 3 divided by 3 is what? 1. 1 times 8 is 8. So this is 8. Is that okay now? So this will give us equal to 2 plus 8 is 10. And 3 plus, and this 3 will bring it down. Remember, in our last class, we said something about the relationship between a mixed number and an improper fraction. Look at this. Is this a mixed number or is this a proper or improper fraction? This is an improper fraction in the sense that the numerator is greater than the denominator. So we change it to mixed number. To change to mixed number is divide this by this. Find the remainder. The remainder is the whole number in your mixed number. That remainder of any division of a fraction, if it has a remainder, that remainder is what we call the whole number of. Okay, so this will be 3 divide 10. It will go 3 times. That is, it will stop at 9. 3, 3, 3. That is 9. So remainder what? 1. Do you understand the point now? Okay, so 3 divide 10, it will give us 3 times remainder what? 1. That 1, we put it here and divide it by 3. Do you get the point now? So what I just mentioned here is that remainder, which is 1, is what you bring out and you have it divided by these 3. But that particular number of times that number is able to go to the numerator is what you bring out as the whole number. Okay, so this is this. All right, so the next one, I think we also have the next one there. The next one is adding fractions with different denominators. Like we have 2/3. We still have this add 2/3 plus 3/4. Now, in this case, we have 3 and 4 as denominators of these two fractions, and they are not the same numbers. So the first thing we do, remember the rule, make sure they are the same number, that their denominators are the same number. And what do we do to make sure that they are the same number? Is to find their LCM. Their LCM, okay? Their LCM is their lowest common multiple, okay? So their lowest common multiple, how do you do that? 3 and 4. 2 here, it cannot go into 3, so bring 3 down, 2 here, 2 here, 3 here, 1 here. 3 is the next that can go 1, 1. So the LCM is 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is what? 12. Okay, the simplest way of doing this kind of thing, if you see LCM of, if you're looking for LCM of 2 numbers or 3 numbers that do not have the same factor, there is no common factor, just multiply the 2 numbers. Like 3 and 4, they don't have a common factor. Do you understand the point now? They don't have a common what? Factor. So this would have just, instead of going through this process, just do 3 times 4 is equal to 12. So this is the LCM. Do you understand me? Because they don't have the same factor. No need of coming to do all this. Do you understand that? All right, so this is 12. So we draw a large line. Okay, so this is equal to a large line. Bring down this denominator now. This LCM, which is now their common denominator. It's now the common denominator for this and this. Do you understand? Then the next thing we did here is as simple as that. This divide this. Okay, the answer, you multiply it by the numerator. So 3 divide 12 is 4. 4 times 2 is what? 8. See that? Then plus comes down. 4 divide 3 is 4 divide 12 is 3. 3 times 3 is 9. Okay? So at the end of the day, we're going to have 8 plus 9 to give us 17 over what? 12. Do you understand that now? This is also an improper fraction. So because it is an improper fraction, what we need to do there is to make it to be a mixed number. How? 12 divide 17, it can only go once. That is 12 into 12. Okay? So it will not be one whole number. What will be left between 12 to 17? 13, 14, 15, 16, 17. So 5 over what? 12. You know this, you can also convert this and this to be this. Okay? 3 times 3 is 9 plus 1, 10. That is this 10 over 3. Here, 12 times 1, 12 plus this 17. That is 17 over 12. So this is the answer of this one. Okay. Now, another way of doing this alternatively, instead of doing all these LCM and all that, the alternative way of doing this is, for example, for this one, this 2 over 3 plus 8 over what? 3. Just multiply here, and multiply here. Do you understand how? What that means is 3 times 8, I think this is 24. 3 times 2 first. Let's start from 3 times 2. This is 6 plus 3 times 8. This is 24. 3 times 3. This is 9. You see that? So 6 plus 24 gives us 30 all over what? 9. Okay. 3 in 30 will give us 10. 3 in 9 will give us what? 3. That is this 10 over 3, which will now be equal to 3 whole number 1 over 3, according to what we were able to do here. The same thing here, okay? Where is the other one? This multiplied by this multiplied by this multiplied by this. Do you get that? Okay? Okay, let's look at it and see what we have there. What is it? 2 over 3 plus 3 over 4 is equal to, so we'll do this multiplied by this multiplied by this, then this multiplied by either this or this, anyhow. So this will now be equal to 2 times this is 8 plus 3 times 3 is 9 all over 3 times 4 is 12. You get that? This times this is 8, this times this 9, and okay, so this will be 17 all over what? 12, which is also the same thing we had here, which will give us 1 whole number 5 over 12. Okay, so that is that. So any of the method that is easier for you. For me, I love using this method. It's easier. Instead of me to start looking for LCM, I'm doing all of that. I just do that and I get my answer. Okay, so let's look at the next thing, subtraction of fractions, how it's done. It follows the same method of addition of fraction. It's just that you have to subtract, of course, not add. Okay, so let's quickly look at it. Let's quickly look at it now. They said we have the first one, same denominator, 9 over 2, 7 over 2. So they say we should subtract 9 over 2 minus 7 over 2. So the same thing, their LCM, since they are the same number, will be 2. Do you understand that? So this divide this is 1. 2 divide 2 is 1. 1 times 7 is 7. Minus 2 divide this is 1 times this is 9. Okay? So this will be equal to 9 minus 7 is 2 over 2, which is equal to 1. Do you understand? Now, you see this thing I did here, drawing this line, putting 2, there may be even no need for that. Once they have the same denominator, like 9 over 2 minus 7 over 2, there's no point doing all that. Just know that this will be 9 minus 7 is 2, and these 2, just bring that one out. Okay? All right? Okay, so that is what you do there. Once they have the same denominator. Same thing applies to addition. Okay? All right, so let's look at for different denominators now. We have 3 over 4, subtract 3 over 4 minus 2 over 3. 2 over 3. So of course, this is different denominators. The LCM of 4 and 3, as we have established here, is 12. So this is 12. Okay. So 4 into 12 will give us 3. 3 times 3 is 9. Minus 3 into 12 will give us 4 times 2 is 8. So this will give us 9 minus 8 will give us 1 over 12. This is an improper fraction. So our answer is 1 over 12. So that is that about how to do operations that is associated with addition and subtraction of fractions. Okay, let's go to the next one. Let's look at multiplication and division of fractions. The first one there, the first question we have there is for division of fractions. After that, we have multiplication of fractions. Okay? All right, so let's look at this. Division of fraction. The first thing we have there, multiplication, right? They say we should multiply 2 over 3 times 3 over 7. Remember, the rule for multiplication says that the numerator has business with the numerator, denominator has business with the denominator. So what that means is this multiply this, and this multiply this. So the multiplication can either be 3 times 2 or 2 times 3. That's why I have the 2 arrows. The arrow pointing this way and this way. It can also be 3 times 7 or 7 times 3. Okay, so this will be equal to 2 times 3 is 6 over 3 times 7 is 21. Now, is this simplified? Is this equation simplified? No, I think the answer is no, because they have the same, they have a common factor. 3 is a common factor, right? 3 into 6 is equal to 2, while 3 into 21 will give us what? 7. Is that okay? So 2 over 7 is the answer of when you multiply 2 over 3 and 3 over 7. The answer is 2 over 7. That is the simplest form that you can have that. Okay? Then the next one is division. So any other fraction you have around this, that is how it is done. Okay? Then the next one is divide. Divide 2 over 3 3 over 7. Okay. 2 over 3, 3 over 7. Now, this thing is 2 over 3 divided by 3 over 7. So this is equal to, remember, when we looked at the rules for simplification of fraction, we said that when we have two fractions dividing themselves, okay? The one up, the fraction up is the numerator fraction, okay, because it is up. While the one down, it is the denominator fraction. So the simple rule is bring out the numerator fraction 2 over 3. Change this one will change to multiplication. How? Because we will now do the inverse of the denominator fraction. The inverse means 7 should now go where 3 is, and 3 should come to where 7 is. That is 7 all over what? 3. That is what it means. Did you get? So this will be 2 times 7 will give us 14. And 3 times 3 will give us 9. So with this, we have been able to divide this and this. But you know, 14 over 9 is an improper fraction. So we need to convert it to a mixed number or to a mixed fraction. So what we do now, how many times will 9 go into 14? Is once. Okay, so what will be the remainder? When you count from 9 to 14, that will be the remainder. From 9, 10, 11, 12, 13, 14. So there will be remainder of 5. So it will be 5 whole number. It will be 1 whole number, 5 over 9. Okay, as the answer to this problem when you divide 2 over 3 and 3 over 7. Is that clear? Okay, so we'll move on to other operations that has to do with fractions. Okay, so let's look at other, let's look at ordering of fraction. You know, it will be so confusing for you to know which fraction is bigger than which. Like when we did, we have something like, we had that fraction on number line. We have 0. We said here is our 1/4. Here is our 2/4. Here is our 3/4. Then here is our, let's say, 4/4, which is equal to 1. Do you understand? Remember, these numbers are increasing from this place as they move right. Do you understand? So it means that 2/4 is bigger than 1/4. 3/4 is bigger than, just like that. Do you understand? So there may be some fractions that they don't have the same denominator. Now, how do we know which fraction is bigger than which? You may be faced with such questions. Do you understand the point now? So let's look at how we can order fraction in their order of magnitude, how we can arrange fractions in their order of magnitude. That is, if in an ascending order or in a descending order. In an ascending order, we mean we go from the least to the highest, okay? While in a descending order, we go from the highest to the least. Is that okay? All right, so let's look at what we have here. Arrange the following fractions in descending order of magnitude. So which, in these 4 fractions we are given here, which one is the highest? Which one is the highest and which one is the least? That's what they're asking us. So we should arrange them. The highest should come first, the second highest, and the third, just like that, until we get to the least. Do you understand the point now? All right, so let's look at that. Let's look at that. So we have to arrange in order of magnitude this is ordering fraction. Ordering in order of magnitude in descending order. So we have 3/4. We have 4/5. We have 2/5. And lastly, we have 1/2. Okay, we have 1/2. Okay, in ordering fraction, look at the steps you must take. First, find the LCM of all the denominators. Find the LCM of all the denominators. So we have 2554, okay? So let's just get somewhere and find our denominator. Just let's take this place. We have 2, we have 4, we have 5, we have 5. Let's just bring them out. What is their LCM? 2 here will be 1, 2, 5, 5. 2 here will be 1, 1, 5, 5, right? Then what do we have next? There are 5. 5 here will be 1, 1, 1, 1. 2 times 2, 4 times 2. 2 times 2, 4 times 5 is 20. So the LCM is 20. LCM of 2, 4, 5, and 5 is 20. Do you understand that? So when we do that the same way, bring them out, put the 20 here as the LCM. Is that okay? Now let's have them. 3/4, 4/5, 2/5, 1/2. All right? All right. The same way, it's just that we're not adding anything here. We are not adding them, but the same thing we do in subtraction and division and addition is what we do here. How? 4 divide 20, you divide this 20 by each of the denominators of the fraction of, even if it's 20 fractions you want to order, you divide their LCM, this is their common LCM now, okay, with each of the denominators of the fractions, okay? So here we have 4 divide 20 will give us 5, right? 4 divide 20 will give us 5. 5 times 3 will give us what? 15. We move to this one. We are done in this one. We move to this one. We have 5 as the denominator of this fraction. So 5 divide 20 will give us 4. 4 times 4 will give us 16. Okay, so this is 16. This one is 16. Just note what I'm doing. Then we go to the next one. We go to 2 over 5. So 5 divide 20 is what? 4. 4 times 2 is 8. So this one is 8. Remember, they all have a common factor, a common denominator now. Then we go to the next one. 2 into 20, 2 divide 20 is 10. 10 times 1 is 10. So, what does this tell us? It tells us that from what we have done here, the fraction with the highest numerator now that we have had a common denominator, the one with the highest numerator, when they have a common denominator, which is their LCM, the fraction with the highest numerator is the highest fraction. The one with the least numerator is the least fraction. So they say we should arrange these in order of what? Magnitude, in descending order. Arrange the following fractions in descending order of magnitude, descending. And I told you descending means from up to down. So our first one there in descending order right, we have 16 is the highest. And which fraction has 16 as numerator is 4 over 5. So 4 over 5. Before you go to 15, that is 3 over 4. 3 over 4. Before you go to 1 over 2. 1 over 2. And lastly, the least is 2 over 5. So without taking this step, you cannot ascertain which of these fractions is the least and which one is the highest. So this is the step you have to take. So if they ask you to arrange, so let's assume the question was arrange the fraction in ascending order. It would have been, for ascending order now, ascending, it would have now been 2 over 5, 1 over 2, 3 over 4, and what? 4 over 5. This is ascending from least to highest. Descending from highest to the least. All right? So that is how to order fractions. Okay? Okay, let's move to the next one. Let's take some exercises from Examguide app. The first question here is on ordering of fractions. So you can see that you have this, you can have this kind of questions appear in your BESE exams, okay? Like look at this one, they said we should arrange 1 over 3, 2 over 3, 1 over 4, 3 over 5 in ascending order of magnitude, and they gave options here for us to pick from. Is that okay now? Okay, so let's go. Okay, so we are given 1 over 3. So arrange in ascending. One over 3. The next one is 2 over 3. The next one is 1 over 4. The next is 3 over 5. Is that correct? 3 over 5, 1 over 4, 2 over 3, 1 over 3. Okay? So what do we do? Like we said, LCM of all these. So let's see 3, 4, 5. Okay? 3 here, 1, 4, 5. Okay? 4 here, 1, 1, 5. Okay? 5 here, 1, 1, 1. So this is 3 times 4 times 5. Remember what I told you? To find the LCM of 3 numbers, 2 numbers, 4 numbers without common factor. Like, look at 3, 4, and 5. No common factor. Just multiply them. 3 times 5 times 3 times 4 times 5. That is what we did here. Is still 3 times 4 times 5. So, what is it now? 3 times 4 is 12. 12 times 5 is 60. So this is 60. Is that okay? So we'll open up here. Their common LCM is 60. So we do for each of them. Okay? So for this one, we're doing 3 into 60. 3 divided 60 gives us 20. All right? 20 times 1 will give us 20 times 1 will give us 20. So here is 20. We come to this point. Okay? 3 into 60 is 20 times 2 is 40. The next one, 4 into 60, okay, is 15. 15 times 1 is still 15. Why the next one? That is the last one. 5 into 60 give us 12. Okay? 12 times 3 give us 24. Is that okay now? So, if we look at what we have here, the highest number is 24, and they are asking us arrange in ascending. Ascending means from the least to the highest. So it means we'll start from the least, which is 1 over 4. So this is equal to 1 over 4, comma. The next one is 1 over 3. 1 over 3. The next one is 24. That is 3 over 5. And the last one is, no. This is 15. 1 over 4. 20. Yes. 1 over 3. Yes. 3. Okay. Then 40. Then 2 over 3. So if we look at the options we have there, we have 1 over 4, 1 over 3, 1 over 4, 1 over 3, 3 over 5, and 2 over 3. That is option B is the correct option. Is that okay? So you pick your option and you move to the next. All right, the next one we have there, it says 1 over P and 1 over Q. Now listen, everybody, just look up and see what I have to do here now. The rule in fraction, addition, or subtraction is that the denominators of the two fractions must be the same for you to do anything. But here, we have P and Q, and they are not even numbers. So how do we find the, what is it called? How do we find the LCM? Simple. LCM of P and Q is simple. P here is 1. Q here is 1 and 1. So it is equal to P times Q is equal to PQ. Is that okay? So we say we open a big bracket and put our PQ here. Do you get that now? Now they have a common denominator because here there is a factor of P here and there's also a factor of P here. Do you understand me? Okay, so P divide PQ, that is P cancel P. That is what it means. What will be left there is Q. So P divide PQ will be Q. Q is the answer. How? If we have P, Q over P. P cancel Q and P, the answer is Q. Do you understand? So P divide PQ is Q. This Q times 1 is what? Still what? Q. We'll bring the plus. Then here we go. Q divide PQ is PQ all over Q. So Q will remove Q to remain only P. Okay? So Q divided by PQ, Q will go off, only P will be left. P times 1 is still P. Is that okay now? Now, what do we do is to now add the two denominators. Is it not? But at this point, you cannot add letters. You cannot add unknown. You cannot add variables because you don't know the particular value of number they are. So it is still the same thing as equal to Q plus P all over PQ as the answer. So the option Q plus P all over PQ. Okay, that is option B. So that is our correct option in that particular. So now they're asking us which of the following fraction is equivalent. Now, if you have if you have listened to our previous class on fractions, introduction to fraction, we took time to talk about equivalent fractions, like fraction, unlike fraction, types of fractions, all those things we did then. So they're asking us here, which of the following fractions is equivalent to 3 over 5? Is equivalent to 3 over 5. So what you have to do there is 3 over 5 is in its simplest form. So all the fractions that you have been given there, quickly look at them. Which one do you think, when you simplify it to its simplest form, it would be the same thing as 3 over 5? Equivalent fraction are fractions that are equal. So which of those fractions, when simplified, is equal to 3 over 5? So let's look at the first one. You know it's definitely not 4 over 18. Because there is nothing, 4 over 18 is not it. Why? Because 3, which is the numerator of 5 in that fraction they give to us, is not a factor of 4. So 4 is out of it. You go to 9 over 27. Well, it is possible only if you simplify it. Now let's look at 9 over 27. Or even, let's even look at that 3 over 4. 4 over what? 4 over 18. 4 over 18. 2 here is 2. 2 here is 9. So this is 9 over 2, which is not equivalent to 3 over 4. So that's why I said that is not even considered at all. Then we have 9 over 27. Look at 9. So this one is no. We also have 9 over 27. Okay? 3 into 9 is 3. 3 into 27 is 7. So 3 over 7. But it is not it, because what we are talking about is 3 over 5. So 9 over 27 is not. This one is not. So let's look at C. Option C says 8 over 16. It will still be not. It will still be. It will not be the answer, because 8. There is nothing common between 8 and 3. How? This is 8 over what? 8 over 16. That is 1 over 2. That is what it will give us. 8 over 16. 2 here will give us 4. 2 here will give us 8. 2 here will give us 2. 2 here will give us 4. 2 here will give us 1. 2 here will give us 2. So this is equal to 1 over 2. So it is not equivalent to what we are talking about. Let's look at the next one. 12 over 20. That might be where the answer is. And let's look at that. 12 over 20. Is that 12 over 20? Yes. Now look at 12 over 20. Okay. Here, 2 can go into this place to give us 6. 2 can go into this place to give us 10. Do you understand? 2 can go into this place to give us 3. 2 can go into this place to give us 5. You see? So this is 3 over 5. Therefore, 12 over 20 is equivalent to what? 3 over 5. So our correct option there is option D, which is 12 over 20. That is the correct option. Okay? Now, the next thing is they are asking us to express a decimal fraction or a decimal number as a fraction. It is very easy to do or to work out. They say we should express 0.65 as a fraction. So in fractions also, we can express decimal numbers. We can express decimal numbers, or we can convert decimal numbers to become fractions. Do you understand the point? This is how to go about it. So let's go. So we're asked to express 0.65 express 0.65 to a fraction. So we bring out our 0.65 to fraction. Our problem here is to remove this decimal point and make this thing a number in fraction. Do you understand that? So to do that, we move this decimal point forward. We move it to where we have this thing so that this 0 can be out and 65 will be a number of its own without a decimal point. Do you understand the point now? So what we do, we move this 1, 2. This decimal point now comes here so that 65 can now be alone. But that does not solve it. Now, for you to move a decimal point from a number means that the number of times you move the decimal point will determine the power of tens. Okay, in terms of 10, 100, 1,000, 10,000, and all that this 65 or this number will now have as a denominator. So this will now be over. How many times did we move this point? It is 1, 2. So because of that, we'll add 2 0. We'll look for the numbers in the powers of 10. All the numbers in the power of 10 that have 2 zeros. The one with 2 zeros. And it is 100. So 100. This 0, 0 means that we move this 1 and 2. Is that okay now? So that is why we'll have this like this. So this has been converted to fraction. This thing is the same as this. Do you understand that now? But you can't keep it because if you check the option, no option is 65 over 10. But you need to do what? Simplify the fraction to its lowest term. How? Let's go. What is the common factor here? 5 is common here, 5 is common here. So 5 into 65 and 5 into 100. That's what we'll do. So 5 into 65, 5 into 6. You know, if you don't know what 5 into 65 may be, just break it down. Okay? 5 into 6 will give us what? 1. That is 5 into 6 will give us 1. The remainder what? 1. So it will be 1. The remainder 1. That 1 we add it to this 5 so that it becomes 15. 5 into 15 will give us what? 3. So it means 5 into 65 is 13. All right? Then 5 into 100 is what? You know that 5 into 10 is 2. Then we'll bring the 0 and put. So that is 13 over 20. Okay? Which is option C as the correct option there. Okay, we have this question. If 6 whole number 3 over 4 is expressed as an improper fraction, its numerator will be, okay, they're asking us, what will be the numerator of 6 whole number 3 over 4 as expressed in improper fraction? So what will be the numerator? Okay, so they're asking us to change that to improper fraction. Do you understand? So that the denominator of that improper fraction is what they're asking for now. Do you understand the point? This is 6 whole number 3 over what? 3 over 4. So they say if 6/3/4 is expressed as an improper fraction. So they say we should express it as an improper fraction. To express this as an improper fraction is to simply change this to improper fraction. Do you understand that? To change this to improper fraction. How is that done? Okay, this multiply by this, then this. The answer we get here will be added to this. Do you understand that now? So this will be equal to 6 times 4. The answer we get, we add it to plus 3 and we divide it by 4. How? So 6 times 4 is 24 plus 3 all over 4. So the numerator will now be 27 over 4. So option E is the correct option. So the numerator of that of that improper fraction is 27. All right? Okay, so let's look at other things. Okay, so you see this, and they say express 0.0504 as a fraction in its lowest form. So is what we just did now. You can try this on your own. You can solve this and put your answer on the comment section, because we just did exactly the same thing now, 0.0504. Okay, they say we should express it as a fraction in its lowest form. Remember, the decimal point is here. So we're going to move this decimal point to at least 1, 2, 3. You know the number of places we have to move the decimal point. Then you know what we now have to add and all that. So do it. Put your answer on the comment section of this video, please. I would like to get the solution of your solving, please. All right, let's look at the next thing. Okay, you also do this for me. On the comment section, you put your answer there. Express 0.25 as a fraction. 0.25 as a fraction. Remember, you will not see your answer if you just change to fraction without simplifying it or keeping it in its lowest term. It is when you keep it in its lowest term that you can see your answer. The lowest term is that term, or is that part of your solving when you cannot do anything further except you want to convert it back to decimal points. Is that okay? So do this again, this number, and show it in your in the comment section. Okay? So let's see the next one. A man spends 1/3 of his salary on food and 1/4 on school fees of the children. What fraction of his salary is left? Okay, let's look at that. Okay. Now, the question says a man spends 1/3 of his entire salary on food. Okay, so a man spends on food, he spends 1/3 of his salary. Okay. Okay, and 1/4 on school fees. One over 4 on food, 1/4 on school fees. Okay, so let's see. So they're asking us what fraction of his salary is left. What fraction of his salary is left? Now, they didn't tell us the salary, if it is, 1 naira, 2 naira, no. They are just asking of the fraction of the salary. Okay, so let's assume for the salary to be a whole. You know that in fraction, we are simply dividing a whole, and a whole is something that is 1. Do you understand me now? 1 is not a fraction. 1 is not a fraction. So it is 1 that we keep dividing and dividing and get whatever I want to get in fractions. Do you understand? So let's assume this salary of this man is 1. Is 1. Do you understand the point? Okay, so let's say this man spent 1/3 of his salary, which is 1. Okay, that is for food and fees. He spent 1/4 of what? Salary, which is what? 1, which is whole. The salary is a whole, so a whole is 1. Do you understand? The salary is a whole. Okay? Before he started spending the salary is whole, 1. Do you understand? 1 full salary. Nothing was taken out of it. So it's 1 full salary. All right. So he spent this on. So this will be equal to, anytime in mathematics you see of, it means times. So this is 1/3 times 1. Do you get that? So this will be equal to 1. Remember the rule, 1 times 1, 3 times 1. So 1 times 1 is what? 1. 3 times 1 is what? 3. Do you understand that now? Why for this one, this will now be equal to 1/4 times 1. So 1/1, okay? So 1 times 1 is equal to 1. 4 times 1 is equal to 4. Do you understand that now? That's the first thing you do. Now, it means, let's know the total things, the total fraction he has taken out of the salary. How do we get the total fraction now? It is to add the fraction of food and fraction of fees. So that is 1/3 plus 1/4. Do you get that? LCM of this is what? 12. Remember, we just did that. So 12, that is 3 times 4, 12. 4 into 12 will give us 3. 3 times 1 is 3. Plus 3 into 12 will give us 4. 4 times 1 is 4. So this will be 7/12. So everything he spent 7/12 of the salary. 7/12 of the salary. That is when we add the fraction of food and the fraction of, what is it called? Of school fees, of the children's school fees. So he spent altogether 7/12 fraction of the entire salary. Do you understand the point now? Now the question is saying, if you look at your options, you have 7/12. Don't be careful, don't go and pick it. Look at what the question is asking you. The question is, what fraction of his salary is left? If he has spent 7/12, okay, out of the salary now, what fraction of the salary is left? So is to subtract the ones he has spent so far from the salary, which is one whole salary, is to remove the 7/12 from that salary to get what is left from the salary. So what is left? Okay, so what is left would be the whole salary. You now remove what he has spent, which is 7/12 from the whole salary. Remember, the whole salary is 1. So this will now be 1 minus, this is salary left after spending. So it will be 1 minus 7/12. Do you understand that now? Okay, any number you see, any number without a fraction, 1, 2, 3, 4, 5, 6 to infinity, they have a denominator that is 1, that is invisible. So there is an invisible denominator of 1 here with this 1, this over 1. Do you understand that? All right, so what do? We look for the LCM of 12 and 1, which is also 12, right? How? 12 and 1, okay? This is 1, here is 1, here is 12, so 12, this will be 1 and 1. 1 times 12 is 12, so this is 12, right? All right, so this is 1 divided 12 will give us 12, right? 12 times 1 is 12. Minus 12 divided 12 is 1. 12 divided 12 is 1. 1 times 7 is 7, right? So this will now be equal to 12 minus 7 will give us 5 all over what? 12. So this will be the leftover salary after spending 7 over 12. So we look at option C there, which is the correct option. Is that okay? All right. So this is saying convert two whole number 2 over 5 to decimal fraction and give your answer to, okay, let's do this one. So just as we converted from decimal fraction to, what is it called? From decimal fraction to fraction, from decimal number to fraction, we can also convert from fractions to decimal numbers. Do you understand the point now? So let's look at that now. They say we should convert two whole number 2 over 5. They say we should convert 2 whole number 2 over 5 to decimal. Right? So to do this, this is equal to 2 whole number 2 over 5. Remember, we've said the rule is, this is a mixed number, so we change it to improper fraction, right? So to do this, 2 will multiply the whole number, 5 will multiply the whole number, which is the denominator multiplies whole number. The answer, we add it to the numerator. So 2 times 5 is 10 plus 2 is 12 all over what? This 5 here. Okay, so this is the improper fraction. So improper fraction, we want to convert it to decimal number or decimal fraction as the case may be. All right, so this is equal to, can 12 be divided by 5? The answer is yes, but there will be a remainder. Okay, that remainder, we also have a business with that remainder. Okay, how? 12 divided 5, how many times will it go? How many times will 12 divided by 5? How many times will 5 go into 12? That is 5 will go into itself 1, will go into 10 2, then there will be leftover, which is 2. That is 5 into 10. That is 2 times, there will be 2 left over. So this will not be 2 whole number. So this will not be 2 rather. So the answer is 2, but there is a remainder of 2. What do we do with this 2? 5 divided 12 is 2, but there is a remainder 2. Because 10, 11, 12, 2 numbers are left before 12. So what do we do with that number? Okay, because 5 divided 12 and there is a remainder of 2, okay, we will add 0 to that 2 because we want to keep dividing it. But once we add 0, we will now introduce a decimal point here. Then add 0 to this 2 because there is a remainder. So 5 into this 2 now that has become 20 because of the addition of the 0 will now be what? 4. 5 into 20 is 4. So this is 4. There is no longer remainder. So 2 whole number 2 over 5 in decimal number is 2.4, which is option B. Okay? Okay? So let's go to the next thing we have here. Now you can see this kind of question. They say evaluate. Let's look at that. Evaluate square root of 2 whole number 7 over 9. Square root of 2 whole number 7 over 9. So this is equal to square root of 2 whole number 7 over 9. So let's do what is inside of this. Okay? Of course, let's change this to improper fraction. 9 times 2 is 18. 9 times 2 is 18. So 18 plus 7. 9 times 2, 18. 18 plus 7 is 25. So this will be equal to 25 divided by 9. Okay? This is also 25. 9 is also the same thing. Do you understand the point? Okay, so root of 25 you know is 5, while root of 9 is 3. Okay? Do you understand the point now? Now, this is 5 over 3. It is improper fraction. If you check your options, no one carries 5 over 3 because they expect you to simplify this into mixed number. So 3 into 5 will give us 1, remainder what? 2. Do you understand me now? So it will give us 1, remainder 2 over 3. Do you understand the point now? 1, so such that 3 times 1 is 3 plus 1 is 5. That's 5 over. So the answer there is 1 whole number 2 over 3, which is option 1 whole number 2 over 3. Option C is the correct option there. Okay? Let's look at this one. Maybe this will be the last example we'll take. Okay? It says, this particular example, it says 4 over 9 of the spectators, 4 over 9 of spectators, 4 over 9 of spectators in a football match are males. You say, are what? Males. Now, if 200 of them are females, if 200 of the spectators are females, how many spectators are there in the competition? How many spectators are there in the competition? Okay, now let's look at this. So, male, okay, 200 are what? Females. Is that okay? So they're asking us how many spectators are females. We don't know how many spectators are in the competition. How many spectators? Now look at this now. The first thing we need to know is they are asking us of the number of spectators. They have said that 4 over 9 of the spectators in the football match are males. So how do we know what the real figure of that 4 over 9 of the spectators, what the real figure is? We don't know. So what we can do at this point is to give the number of spectators in the field to be anything. So let's assume, let the number of spectators, both male and female, spectators in the field be X. Let's say X. Do you understand that? So look at now what the question is saying. The question is saying that 4 over 9 of spectators, that is 4 over 9 of X, that is, so this simply means that 4 over 9 of X plus 200, remember this 4 over 9 is males, right? That is males now. Plus females. Female, they say, is what? 200 of them. So they will give us what? Total what? Spectators. What is our total spectator? X. Do you get that? So 4 over 9 of X plus 200 will give us the total number of spectators. Do you understand that now? Okay. So what that simply means is 4 over 9 times X plus 200 is equal to X. So this will be this over 1. Remember the rule of multiplication, numerator, numerator, denominator, denominator. So this will be equal to 4x over 9 plus 200 is equal to x. So this will be over 1. Do you understand the point now? So let's look for the LCM of this. Is that okay? So LCM of 9 and 1 is 9. So this 1 into 9 is 9. 1 divided 9 is 9. So 200 times 9. 200 times 9. 0, 0, 18. So 1,800. So this is 1,800. Is that okay? Plus this is 1. That is 9 divided 9 is 1 times 4x is 4x is equal to what? X. Okay? All right. So what we do here, this is over 1. We take like 10. We cross multiply. So this will be equal to 4x plus 1,800 times 9 times x. Okay, this is what I'm talking about now, over 1. We say we'll cross multiply. It means this one will multiply everything here. So it will be 4x plus 1,800 because 1 times 4x is 4x. 1 times 1,800 is 1,800. So we are done with this multiplying. Then here we have 9 times x to give us 9x. Is that correct? So we are having now, what is that called now? We take like terms. Let this 9x come over to where x is, okay? And let 800 go to where there is no x. So we have 4x minus 9x, because when minus crosses over to this side, to this equal sign, this plus sign that is invisible here changes to minus. Is that okay? So here we have it as minus 9 to be equal to 1,800 now comes to this place. This plus changes to minus to be minus 1,800. Okay? So this will be minus 4x, 4x minus 9x should be minus 5x, because a bigger number is subtracting a larger number. So it will be a negative sign. Okay? So this will now be minus 1,800. Okay? So let's look at what is happening there. Okay, so we have minus 5x is equal to minus 1,800. Is that okay? So what do we do to, remember, we want to know what x is, what the total number of spectators is, which is what they're asking us. How many spectators are in the field, in the competition? So what do we do to make this x subject is to divide both sides. Divide both sides by the coefficient of x. Coefficient of x is minus 5. That is, the coefficient of any variable is the number that is multiplying it, that is behind it, that is at the back. So it is minus 5 that is at the back. So we have minus 5x divided by minus 5 is equal to minus 1,800 divided by 5. Is that okay now? Okay, so we have minus, we'll cancel this minus, 5 will cancel 5, we'll have x left alone. Okay, this minus 5 to this minus 5 rather. Minus will cancel this minus, so we'll have 5 divided by 1,800. Okay, how do we go about that? 5 divide 18. Look at that. Because this number is large, you may not know. So take it bit by bit. 5 divide 18, you start with that. Will give us what? If 5 divide 18, it will give us 3. Because 5 divide 15. 15 is the closest number to 18 that 5 can divide. Right? So 5 divide 15 is 3. And there will be a remainder of what? There will be a remainder of 3. So that 3, we put it to this first 0. It becomes 30, right? 5 into 30 is what? 5 into 30, you know, is what? 6. Is 6. And this 0 now will not be added here. So it is 360. 360 people. So there's 360 spectators. So our number of spectators is 360, which is option A. So it means that total number of spec is equal to 360. Okay, what that means is that if female
we have it as 200. It means that male will be equal to what? 160 males. Is that okay? That is what that means. Okay? So this is how much we can take on some of the operations, some of the word problems that are associated, that are related to fractions. So you can go through the video over and over again and get master with some of these concepts that we have here. Thank you very much. I will see you next time.